down. Good morning. You're on the right day this time.
Huh?
You're on the right day this time.
Oh, yeah. Are you done with all your AP testing?
No, I've got Tuesday. Tuesday is AP language.
Oh, yeah, that's gonna be a big one.
Yeah, it won't be that bad. The mock exam was I had a quick question about the book assignment. I got to 59 and 60 and had no idea what to do.
Okay, so you watched the class video.
I was here when we went over a lot of it, but this one I
One
didn't.
day you were not here, we went over it in class.
Oh, darn. Okay.
So you need to start there and then see what that answers for you.
Okay.
And I also have it pre-recorded on the resource page too from past years.
Oh, okay.
So I don't mind helping you pass that, but you need to do that first.
Okay.
I know I have a lot of AP language students, so I probably won't get much done on Tuesday.
Yeah.
I think all my classes will be pretty empty.
Yeah, there's gonna be a lot of people out from the school because it's either regular English 11 or AP language and comp. There's no middle.
Oh.
Unless you take a different kind of course.
Yeah, but that's still just 11th graders.
Yeah.
They're still going to be all the 9th and 10th.
You have 9th and 10th graders?
Oh, well, I mean, I have 9th grade advisory, and
Oh.
I might have a 9th grader or two. I don't think I have any this year.
Yeah, I was like a 9th grader in pre-cal? Good grief.
We have, you know, our Fayetteville Virtual Academy. I can't remember his exact grade. I think he's 7th or 8th grade. And he's doing Calculus BC right now.
That's ridiculous. That's ridiculous.
No, I think he's good at it too, because he did the ACTM contest and got like 4th place or something. So.
Oh, that's stupid. No. No way. No, there's no way.
But yeah, there's probably a handful of 10th graders in here, even in this class.
Oh, yeah. 10th graders I can see. But 9th graders?
Good morning.
Good morning. Hello.
I didn't even look to see which AP tests were today, so.
Oh yeah, yesterday was AP Stat and it was very difficult.
Oh.
It was not great. That far cues made no sense.
It was, well, surely you knew it was going to be hard though.
I did. Apparently the curve on that test is like really big because they make it very hard.
Calculus is the same. Like
Yeah.
if you can get 50% of the points in calculus, you've got like a 3 or maybe a 4.
That's crazy.
Yeah, I think.
Yeah, just wait till you see how hard it is, and you won't
Not
disagree.
looking forward to. I mean, kind of. I don't know. I like math and science, so I'm looking forward to it. I hate English and history. But
I've got my AFLAC test on Tuesday.
oh yeah,
Can't
same.
wait.
Same.
Yeah, but if you're not majoring in something with English, then like I majored in math, so I only had to take like 3 English classes in college.
That's so nice.
And if y'all pass that, like you might only need like 1 or something.
Yeah. Are you gonna be the like only calculus teacher next year?
No, me and Miss Cross usually split them up.
Is there any way like I could like for sure have you, or is it just like random?
I think it's pretty random.
Okay.
I know I don't have any say in it,
Okay.
but Miss Cross is a good teacher. She's been teaching a lot longer than I have, so.
Yeah. I don't know, but I like you and I like this class.
Should I grab these?
If you want to participate, that's the part that won't be on your final, so.
Okay.
What kind of math did you major in, or just math?
Applied math.
What is that?
What you guys have learned is pretty much all applied math.
Oh, okay.
You can either like focus on applied math, which is like stuff that either like real life application stuff or stuff that could be used for real life application. You can be a statistician where you just focus just on statistics,
Mhm.
or you can go into pure math, which is like, you remember like commutative, distributive property,
Yeah.
associative property. So just like understanding the relationship between numbers and theorems,
Mm.
and it's much more like, it's not stuff that you can like use day to day. It's kind of like the art of the relationship of numbers. That's how I would describe it.
Interesting.
So some people make careers out of it.
What kind of career would that be? Just like, I don't
A
know.
university professor.
Okay.
You teach a few classes and then you would research new mathematics and publish papers and get it put in magazines and books
Oh
and
wow.
make the university look good, and that's your job. You just do that all the time. What in the world? Okay, well it is time to start. I don't know.
Whoa. Isn't it 5 minutes later today?
Oh, that's right, yeah.
Yeah.
Oh, okay.
I forgot. Some things I say 20 times and y'all don't hear me, but I say that one time and no one misses it.
Yeah.
I do not understand the when they do that switch, or they change when 0 hour starts.
The 5 minute difference isn't
Yeah,
gonna
it
do well.
doesn't change anything.
No, not for 0 hour.
Well, and then I felt bad. The ACT Aspire days, we started like 20 minutes late, I think. I don't know if y'all remember that.
Was not here.
Well, I told y'all that because that's what the schedule said, but then they fixed it back to 7:15, but it's after I'd already seen y'all, so I didn't like penalize anybody for it, but just not very organized.
Yeah, that's a good job for it.
Did you end up having trials next time?
Yeah.
Is it raining? Oh, that's Thursday. I do too, it's up to them.
You watch my time. I said it everywhere. It's just
Okay. Parker's to that. Connor, Everett. Caden is not. Walker is not. Okay, we need to get started, I guess. Even with the extra 5 minutes here, it's time to get going. One is not. Please. Alex is here. Okay, I'll check that later. Okay, so y'all had a ton of handouts to pick up this morning, but this is our work for today and our work for Monday, and I have all the questions spaced out quite a bit to make sure that it's not too rushed or too compacted. But we need to review the 3 things that we had talked about with rational functions at the end of last class, and then we need to add on the other stuff to that and then start to try to figure out what these graphs look like without a calculator. And it does take quite a bit of practice, which is why it's such a big handout. But also, it just kind of depends. Like, there's 3 different things you could do for horizontal asymptotes, so you have to practice at least 3 questions just to even see one of each of those types. So let's go ahead and start off with the 3 that we talked about last time, and I highly encourage you on this. Later on I'll encourage you to go back and reword all of it, but for the 3 we talked about last time, you probably know a way that you would prefer to word this. So the way this is set up is we've got this one big box on the front page, and this is where we'll have all of our notes for all of the different things we'll need to find. So it's all in one location, and then as we move through these questions, I hope that you feel like you have to go back and refer to this box less and less and less. But we talked about how to find x-intercepts last class. This is again, feel free to reword it in a different way that makes more sense to you. But x values that make only the numerator equal to 0. Underlining and highlighting the word only. We saw that was important. We talked about how to find vertical asymptotes. Those occur for any x value that make only the denominator equal to 0. And the word only here was important as well. And both of those onlys are important because if it's both, it's neither one of these. If it's both, then it's going to be a whole instead. A wholes is going to occur at the x values that make both the numerator and denominator equal to 0. So those underlined and highlighted words there make it where each one's unique. If at x equals 3 is an x-intercept, then it does not make sense for it to also be a vertical asymptote or a hole. Visually, it can only be one of these three things at a time. Likewise, a vertical asymptote could not be an x-intercept or a hole, and a hole cannot be a vertical asymptote or an x-intercept. Now, actually, for this one, I'm going to leave a little bit of space here because we also have to remember how to find the y values, because this is just the x value. So the y value of the hole came from plugging in the x value into the reduced fraction. Now again, these definitions are just the way it clicks in my head, so if you're not sure of any other way to reword it for yourself, go ahead and copy down what I have now, but at the end of class you may go back and add some more details, add a quick example to the side, elaborate, whatever. These notes here are really for you. But let's look down, as you guys finish copying this, let's go ahead and work these three parts of questions 1 and 2. So a quick little review of what these, how to find these and what these look like. Then I'll start to tell you the rest of the notes for the rational functions, and we'll practice them as we do that. Okay, so for both of these, we need to know what numbers make the numerator 0 and what numbers make the denominator 0. Well, in this question, 1 never equals 0. You set 1 equal to 0 and try to solve. It doesn't work. For the denominator, it looks like he could factor out a 3. No, I didn't factor out this 3. And a plus 3 minus 2. So if something's already factored, it's pretty quick, but if it's not factored, we need to factor it. So I factored this denominator by factoring out a 3, and then I did guess and check, and then I can set each of these factors equal to 0. 3 never equals 0, but x plus 3 equals 0 at negative 3, and x minus 2 equals 0 at positive 2. Okay, I'm going to just go ahead and do the same thing for question 2. Now notice, this one doesn't factor the numerator or the denominator, so that's nice. Some of these are going to be a pain in the butt for factoring, but not every question even needs to be factored. And then we should be able to answer 3 of these blanks and update that information on the graph. So x-intercepts are numbers that make just the numerator 0, and in question 1 there's no value that makes the numerator 0. So this guy does not have any x-intercepts. Don't leave that blank, because then it looks like you don't know what you're doing. It looks like you don't know the answer. Over here, the number 2 makes just the numerator 0. So I know over here, the only x-intercept is that x equals 2. So we can add that to our graph and or add it to a table. I know one piece of that graph. The vertical asymptotes are going to be vertical lines that make just the denominator 0. So in question 1, that's 2 of them. When x equals negative 3 and when x equals 2. You do need the x equals part because they are vertical lines. And like all other asymptotes in mathematics, you should graph those as dashed lines. And those are actually really helpful for our graph. It'll take us a few minutes to get there, but those are big keys into figuring out what this graph is going to look like. With question 2, there's one number that makes just a denominator 0, so that would be his vertical asymptote, x equals 4. And then finally, holes occur for any number that makes the numerator and denominator 0, the same x value. That doesn't happen on question 1, and it doesn't happen on question 2. And again, this is why you have to practice a bunch of these, because not every question is going to have a hole. Not every question is going to have an x-intercept. Not every question is going to have a vertical asymptote. You have to practice several of them before you even get a chance to practice all of them a few times. So those are the 3 things that we ended last class with. So hopefully these are the parts that you feel okay with. Is there any quick clarification you'd like on those 3 parts before we branch out? Okay, then let's go back up here. I think probably the easiest part is going to be y-intercepts. Y-intercepts occur when x equals 0. So pretty much you just plug in 0 for all of your x's and solve for y. Y-intercepts occur when x equals 0, just like all other algebra stuff. So if we go down here and do that in question 1, you could either plug it into the original function or plug it into the factored version. Sometimes plugging it into the factored version is easier. It's up to you. But I would get 1 over 0 plus 0 minus 18. So when x is 0, I get 1 over negative 18, or negative 1/18. And that's super close to 0 on the bottom side, but that is a point. That is one definite point I know about my graph now. So add that here. Do the same thing with number 2. If I plug in 0 for x and solve, I get negative 2 over negative 4, which reduces to 1/2. So when x is 0, y is 1/2. So that's one of the easiest random points to get, just because when you're plugging in 0 for x, a lot of stuff just goes to 0. Okay, we'll worry about domain at the end. So next up, let's talk about horizontal asymptotes. And we actually talked about this a little bit earlier this year, because you do need to know about horizontal asymptotes for one type of limit question, limits as x approaches infinity or negative infinity. But this is where you're going to compare the degrees of the numerators to the denominator. So if you have the degree of your numerator is bigger than your degree of your denominator, one thing can happen. Or your degree of your denominator could be bigger. So a second thing could happen. Or the degrees could be equal. Degree of the numerator equals the degree of the denominator. So that's why there's 3 rules, because it just depends. The numerator could have a bigger degree, the denominator could have a bigger degree, or they could be equal. So that's the first thing you have to check. Now, if the degree of the numerator is bigger, it does not have a horizontal asymptote, which is kind of unfortunate because it does help us with the graph. If the degree of the denominator is bigger, it's y equals 0. And if the degrees are equal, it's y equals leading coefficient over leading coefficient. Again, feel free to completely reword all of that as you see fit. This box is really just a resource for you to refer back to. So if you know this definition and you know what you're checking for, this at least doesn't take a lot of work. It's usually the answer is just right there in front of you. But let's do this for questions 1 and 2 and put them on the graph if they have them. So in question 1, the degree of the numerator is 0 because there's no x's. The degree of the denominator is 2. Anytime the degree of the denominator is bigger, your horizontal asymptote is y equals 0. Like all horizontal asymptotes, you should graph as a dashed line. Over here in question 2, the degree of the numerator is 1, the degree of the denominator is 1. So your horizontal asymptote is going to come from y equals 1 over 1. Same thing, it's an asymptote, so graph that line as a dashed line. Okay, and then we just haven't seen one yet that doesn't have a horizontal asymptote. But if the degree of the numerator was bigger, it wouldn't have a horizontal asymptote. Okay, next up, let's talk about slant asymptotes, also known as oblique asymptotes. Same thing, if your teacher said something different. This is one of those things, like in America, we call them slant asymptotes usually, and most of the rest of the world call them oblique asymptotes, but it's the exact same thing. So slant asymptotes are a pain to find, but we don't have to find them all the time. So first off, you need to know when it's even going to have one, and this is when the degree of the numerator is 1 bigger than the degree of the denominator. So if the degree of the numerator is not 1 bigger than the degree of the denominator, then we can just say it doesn't have one and move on. But if it does, the how we find it is we have to do long division, and our slant asymptote will be y equals whatever the quotient from long division is. So we will, whatever the remainder is, it gets ignored. The remainder has no bearing on the slant asymptote. Y equals whatever the quotient is. Okay, so let's apply this to questions 1 and 2. I'll put all this back up again if I need to, or here in a bit. So in question 1, the degree of the numerator was 0, the degree of the denominator is 2, the degree of the numerator is not 1 bigger than the degree of the denominator, so this guy does not have a slant asymptote. Quick and easy. Degree of the numerator is not 1 bigger than the degree of the denominator, so this guy does not have a slant asymptote. I would like to go ahead and just keep looking at question 3, 4, 5 until we find one so that we can practice one together. So question 3, the degree of the numerator is 1 bigger than the degree of the denominator, so this guy does have a slant asymptote. So again, we don't have to do this often, but when we do, unfortunately, because it takes a minute, we have to do long division here. So we're going to have to divide this into the numerator. And our slant asymptote equation is going to come from y equals just the quotient part of this long division. Now, if I remember right, this one's a little bit messier than normal, just because it like throws some fractions at us. But so the way I would deal with this is kind of in 3 parts. I know x times x gives me x cubed. I know a negative times a negative gives me a positive, and 1/3 times 3 gives me 1. So that's how I can figure that out. Negative 1/3 x times negative 3x squared is what gives you positive 1x cubed. Again, I did that in 3 steps. I knew I wanted a positive, so negative gives me a positive. I knew I needed a 1, so I said 1/3 times 3 gives me 1. And then I needed one more x. X times x squared gives me x cubed. Okay, then you need to multiply by these other 2 things too. So x times x would be x squared. Negative times a negative would be positive. And 1/3 times 3 would be 1. And then multiplying it to the 18, I've got a negative times a positive would be negative. 18 times a third is like dividing by 3, so that would be 6. And then x times no more x's just gives us 1x. And then we're going to change the signs and add. See, this would be plus. Okay, just that. And then looks like we could go one more time. So the thing times negative 3x squared, that gives me negative 2x squared. Again, do it in, again, this is the extreme example of long division, but just do it in 3 steps. Positive times a negative gives you a negative. I don't need any more x's. I've already got x squared and I want x squared. And then to what you can multiply by 3 to get 2 is, well, you could divide by 3 to make it be 1, and then you can multiply it by 2 to make it be 2. So 2/3 is what we're looking for there. So when I multiply this, I get that. Also multiply it to here and to here. When I'm multiplying 2/3 by 18, again, it's just like dividing by 3 and multiplying by 2. So 18 divided by 3 would be 6, times 2 would be 12. Now, usually when I start getting near the end of a slant asymptote type question, I start to go a little bit quicker, because technically, if there is a remainder here, like this one has, the remainder just has no bearing on the slant asymptote equation. It was only the quotient that we care about. So once I get this correct, if I can tell that I'm at the end and I'm really only factoring in the remainder, I'm not too worried about that because it's not going to mess anything up. Okay, so that would be the equation of the slant asymptote. Now this is, once again, a 3rd type of asymptote. So we will want to graph this on our line, but as a dashed line. So your y-intercept's about 2/3. It's going down 1 to go right 3. So there's going to be a slant in our graph right there. Okay, so what's important right now, obviously more long division practice is never bad, and you'll get some more practice on some of these. But you have to remember when to do it, because you don't want to do this on every question when it doesn't even make sense. So question 1 and 2 we didn't do it, and question 3 we did, because the degree of the numerator has to be 1 bigger than the degree of the denominator. Then the part of your answer that you need is y equals whatever the quotient is from long division. Since it's an asymptote, we graph it as a dashed line. But we will get to practice that several more times. Okay, and then finally, this is kind of a weird one for notes, but domain, just like we always do with domain, is a way to describe all of the x values of the function or his graph. So basically, what x values can you plug in? What x values make sense to plug in? Well, there's really only two things that are going to mess these up: holes and vertical asymptotes. The only numbers that we would need to take out of these questions are numbers that try to make us divide by 0. So notice, if I look down here, I haven't graphed this yet, but this part of the graph's going to exist. Everything from negative infinity till you get to -3. And it can't equal -3 because we have an asymptote there. That's division by 0. And then it's going to hit all of these x values, everything from -3 to 2. And then it can't be 2 because there's division by 0 there. Whether that's vertical asymptote or whole, either way we have to take it out. But then after that, everything after 2 is also going to be part of our graph. So just see the kind of sections there. Okay, if we do the same thing for question 2, this guy doesn't have a hole, and there's only the one vertical asymptote, so it looks like our graph is going to exist for all of these x values, everything from -infinity to 4, and then all of those x values, everything from 4 and bigger. A long-winded way to say that you can plug in any x value except 4. Don't include 4, don't include 4. Take the numbers less than it on the left and the numbers bigger than it on the right. Okay, and then we really just need 2 more things to be able to know what these graphs look like. Actually, less than 2 on some of them. But you have to know how your graph is going to behave around asymptotes, and sometimes you need more points, which is why I have a little table printed out for us here. So I'm not going to try to find out when x is 10. First off, that's off the graph, and that's going to be really big numbers, and we're trying to do this without a calculator. If we have a calculator, we could just graph the thing in our calculator and be done with it. So I would plug in something easy, like maybe x equals 1, just because I think I can keep up with that one in my head. That would be 1 over 3 times 1 squared plus 3 times 1 minus 18. So -1/12. So still almost 0, but it's a little bit bigger. And believe it or not, if you know how these graphs are going to interact around their asymptotes, which is what I'm about to tell you, we are ready to graph the rest of these graphs, even though I have almost no points on here. So it doesn't seem like this is very significant, but the fact that this is a little bit bigger than this, I'll write this, -1/12 is a little bit bigger than -1/18, tells me that the shape of this graph, this guy's heading down here. Well, at vertical asymptotes, this is where your graph is going to spike to infinity and spike to -infinity. And it just depends on which direction the graph's going. So the fact that this one's going down must mean that he continues to go down, and he shoots to -infinity on this side, which means he's going to shoot up to +infinity on that side. Likewise, over here, if we've got the shape of this, actually, I guess to be fully safe, we should probably try to plug in -1 and see what's going on here. So plug in -1. We get -1/18. So it looks like it must be going, these two are the exact same thing. So it must be here, going up some, and then coming back down. Again, you're welcome to plug in more points. I'm trying to do this as in little points as possible. But I can tell that the shape of this graph, this guy's heading down. So when it gets to this vertical asymptote, he either has to spike up or spike down. So based on the shape of the graph, the direction of the graph, he's spiking down. And if he's spiking down on that side, he's spiking up on this side. So that's what you need to know about the interaction around vertical asymptotes. One side goes to infinity, the other side goes to -infinity. You just need to look at the shape of the graph and the direction of the graph to know which side it's going to. For horizontal asymptotes and slant asymptotes, they tell you what's happening at the end of the graph. So as x gets really big, my graph is going to get close to 0, and as my x gets really small, my graph is going to get close to 0. Horizontal and vertical asymptotes, horizontal and slant asymptotes tell you what's happening at the ends of your graph, the y value that the ends of your graph are approaching. Okay, over here, this one's going to take even less work to be sure about what's going on, because I've got 2 points just from being asked stuff up here already. So I know these two are going to be connected, and the fact that it looks like he's going down means that he's going to continue to go down, and then we know it has to spike at this vertical asymptote. So if he's going down, he goes to negative infinity on the left and positive infinity on the right. And just like this guy, the horizontal asymptote told us the y value that it approaches on the far left and the far right. Same thing with this graph. He's going to approach y equals 1 on the far left and 1 on the far right. Now, I would insist that you graph these to visually see and confirm that all of this is matching up. They currently have my calculators right now for AP testing though, so unless you have your own calculator, you can't really do that today. Okay, let's go back and finish question 3 now, and then I will start asking you to do some guided practice where you try it before we talk about it. Okay, so question 3, we already did the slant asymptote, just so that we have some practice on that. But realistically, when I ask you to try question 4 before I go over it, you can do these in any order that you want to. I would highly encourage you to start with the ones you're most comfortable with, most confident in, do those. Then try the ones you're a little bit less confident on, and then the ones you're the least confident on, read the notes in the box on the front page before you try them. But the ones we talked about last class, I know I need to know what numbers make the numerator and denominator 0. So personally, I'm going to factor the numerator, and he has a GCF and a trinomial. And now I can see that he equals 0 at 0, -2, and 3. And if I factor a GCF out of this one, and then factor his trinomial, I can see the denominator equals 0 at -3 doesn't equal 0, so that doesn't give me 1. -3 and +2. So there's going to be the vertical asymptotes for any numbers that make just the denominator 0. This one has 2 of them. So I'm going to start throwing this stuff on my graph. X equals 2, x equals -3. Dashed lines because they're asymptotes. Any number that just makes the numerator 0 is going to be x-intercepts. So there's 3 of them in this question. 0, 0, -2, 0, and 3, 0. Those are points, so you should write them as points. 0, 0, 3, 0, -2, 0. Should be the only place it touches the x-axis. And if there had been a number that's in both lists, that would be a whole, but this just doesn't happen in question 3. Okay, so we practiced those last time. last class, this is why I tried to break that piece of information off for you so that it didn't feel like just avalanche of information. Hopefully you feel okay with those. So then y-intercept, if you have to go back and look at it, you can, but it's just when x is 0. So if I plug 0 into this, I get 0 minus 0 minus 0 divided by 0 minus 0 over 18. 0 divided by 18 is 0. Now that one should have been obvious because the origin is not just an x-intercept, the origin is also a y-intercept. So I really knew that, but it's good to confirm it. Okay, horizontal asymptotes, we have to, I guess I should put these in my table. Sometimes like on a test we'll say you need to make 5 points at least or something, so might as well throw these freebies in there. But horizontal asymptotes, this is where we have to compare the degree of the numerator to the degree of the denominator, and it depends on which one's bigger. The degree of the denominator is bigger, it's y equals 0. The degree of the numerator is bigger, there's not one. And if the degrees are equal, you put leading coefficient over leading coefficient. This one does not have one. Also, if you really think about the definitions, it's not possible to have a horizontal asymptote and a slant asymptote in the same question. You could have one or the other or neither. Okay, and then I'll come back and do domain at the end once our graph is finished. But we are pretty close to being done here already. I would maybe suggest plugging in another point. Don't try to plug in the point 5 because 5 is going to be really hard to compute without a calculator. But -1 may not be too bad. If I plug in -1, this is what the numerator looks like. And that reduces to 1/3. And there's not anything special about -1 other than I think it's just an easy one to compute. But we can throw that point on the graph. And again, you don't need 1,000,000 points. Obviously more points is better. That's what your calculator does. Your calculator just throws in hundreds if not thousands of points and plots them. But we have plenty if you know how your graph behaves around the asymptotes. Because of these 3 points, I can kind of see this is kind of turning around here. And this is enough for me to see the shape of the graph. From here to here, he's going down. So he must be going to negative infinity on the right side of this vertical asymptote, which means he's going to positive infinity on the left. Based on the direction of this graph, he's going down. So he must continue to go down. So he goes to negative infinity on this side of the vertical asymptote, which means he's going to positive infinity on the right side of this asymptote, which is consistent with this point because I know it's supposed to hit this x-intercept too, so I can go ahead and connect those. And just like horizontal asymptotes tell you what the ends of your graph are doing, slant asymptotes tell you the same thing. Slant asymptotes tell you what your graph is approaching as x gets really small. So as x gets really small, he's trying to approach this slant asymptote line. And as x gets really big, he's trying to approach this slant asymptote line. And again, if you have your own calculator, I think there is some benefit to graphing it and seeing that all of that is correct. And if we had calculators today, then I don't know. When you try some on your own, it usually gives you a good hint if something looks wrong. Okay, and then finally, domain, and then I'm going to have you start to try on question 4 to see what's sticking. So now we can see the whole graph. We can see what x values are being skipped. I hit all of these x values, so everything from negative infinity up to -3. Negative infinity, -3. Then I hit all of these x values, which is -3 to 2. And then finally I hit all of these x values, which is 2 to infinity. I'm trying to color those a little bit for you just to help you see. Domain is not as complicated as you guys try to make it be sometimes. But now, if there was a hole and I was skipping another value, I'd have to make sure I don't include that in my domain, but that hasn't happened yet. Okay, so finish copying that one down, and then I'd like you to try question. Yes, sir.
Do you show the box with like all the words in it for the rules?
Yes, I'll slide that back up. Let me leave this up for one more second though. So I want you to try question 4. So again, there's a handful of things here. So start off with the ones you feel most comfortable with. Hopefully you're not looking at the notes for those. Do however many you feel good about. Then when you get to the ones you're less confident about, go back to the box on the front page. Use that as a tool to see if that helps you answer maybe 1 or 2 more. And once I have given everyone, I don't know, 4 or 5 minutes here to really give it a good shot, I'll go over it, and then hopefully that helps you with the parts you feel less comfortable about. And then each time we do one of these, it should get a little bit easier, a little bit quicker, a little bit less of flipping back to your notes. And by the time we end up practicing all of these between today and next Monday, you should feel like you know the rules pretty well. Now, of course, if you remember this pretty well from Algebra 2, you don't have to sit there and wait for 4 or 5 minutes on this question. Feel free to do what you can, and if you're stuck, go ahead and just start the next question. Yes, I'll make a.
Put my name on it.
Wait, what is that? I don't recognize it.
The
Oh, the review.
just the back page.
I'll have to make these in gradebook and then I'll give them back to you. Thank you. it's already been 5 minutes, which I realize may not be enough time for you to finish this one, but again, as you practice these, they should be getting a little bit quicker each time. So everyone's probably working them in slightly different orders, but I would say of all of these, probably the single easiest is y-intercept, because all you need to do is plug in 0 for x and solve for y. 0 plus 0 minus 6 over 0 minus 0 minus 12. Negative 6 over negative 12 reduces to 1/2. And as you guys have seen in the first couple questions, we don't need 1,000,000 points. Usually 3 or 4 points is plenty. So having 1 point already is a good sign. Okay, the stuff we talked about last time, poles, x-intercepts, and vertical asymptotes all depend on what numbers make the numerator and denominator 0. So you should have factored the numerator, and if you factored it correctly, you see that 2 and negative 3 make it equal to 0. And then to factor the denominator, you really should do a GCF first. If you don't do GCF, then you're making it a lot harder to factor. But if you factored it correctly, negative 4 doesn't equal 0, so that doesn't help, but x plus 3 does, and x minus 1 does. And this list of numbers is going to help us with 3 of our answers. It's almost 3 of these blanks. Any number that makes just a denominator 0, horizontal asymptote, shows up as a dashed line. Any number that makes just a numerator 0, x-intercept, so another point. And then any number that makes both the numerator and denominator 0 is the x value of the whole. So this is the first whole we've seen today. To find the y value, and this part I would emphasize because this part doesn't stick for students as much as some of the other stuff does. And again, it's partly just because it doesn't happen on every question. But you need to plug this in to the reduced fraction. So after it's factored, let some of the terms cancel out and then plug it into what's left. Negative 3 minus 2 on top, and negative 4 times negative 2 on bottom. So negative 5/8. Now, even though that's a spot on the graph that my function's not going to hit, this is actually still really good news for us. We need to show it on our graph as an open circle. When x is negative 3 and y is about negative 5/8, open circle because it's a hole. But even though it's skipping that point, it's going to hit all the points right before it and all the points right after it. So that's actually going to be really good. It's just as useful as a real point. Okay, for slant asymptote, this is the one you have to do long division and keep y equals the quotient and ignore the remainder, but only if the degree of the numerator is 1 bigger than the degree of the denominator. Since that's not true, we don't have to jump through those hoops in this question. Horizontal asymptote, you also have to think about the degrees. If the degree of the denominator is bigger, it's y equals 0. If the degree of the numerator is bigger, it doesn't have one. And in this case, if the degrees are equal, it is y equals leading coefficient over leading coefficient. Okay, that's an asymptote, so dashed line. Now it is kind of important that you put these in the right spots. Like, you want the asymptote above where the hole is. That's going to help us with our graph. If we get those switched up, it's going to be confusing. Okay, and then again, the domain's a lot easier after you finish your graph because you can kind of visually see which x values you're trying to skip. So let's look at our graph and see what parts we are sure about and see if we need to go find some other points by just plugging in x values and solving for y. Well, I know I have these 2 points, so they're going to be connected. Now I can see the direction of my graph. So it looks like it must be going to infinity on the right side of the asymptote, which means it's going to negative infinity on the left side of the asymptote. Even though it doesn't hit this hole, it's going to hit the points right after it and the points right before it. So that helps me connect those. And for slant and horizontal asymptotes, it tells you what the far left of your graph approaches and what the far right of your graph approaches. And so sometimes I need an extra point or two to be sure, but this one didn't need anything else. Those asymptotes and that hole and those points where they were, I've got plenty to feel very confident about this. To finish up the domain, so we're finished with this one. We need to look at the x values that are being hit. Now remember, hole is part of this equation too. So it's hitting all of the x values from the far left until x gets to -2. X can't be -2. So this represents negative infinity to -2. Then it hits these x values from -2 to -1. And then it hits all of these x values from -1 forever to the right. So again, basically I'm just saying you can't have x equals -2, so this is how we say we skip it, and x can't be -1, doesn't exist, and that's how we say we skip it. So this would be the domain. So let's copy it up here. Okay, so I know you have the notes in the box, but now would be a good time if there a specific question you guys have, any of that I'm going over too quickly and you're not able to update your notes or follow along too. Okay, then let's try it again on question 5. So again, start with the ones you're most confident with. Hopefully you're feeling like a couple of them are not much of an issue. Then start leaning on your notes, but try to lean on your notes a little bit less than you did on question 4. As long as you wing yourself off, you'll be fine by the time you're done with all this practice. Question 5, make sure that you don't miss this negative sign because that would mess a lot of stuff up. You might want to just move it up here like that. If you did not see that negative sign, then your graph might be completely upside down. Okay, before I go over this one, I'm actually going to graph it because this is what I would normally ask you guys to do. But again, since we don't have classroom calculators today, I won't make you do it on your own. But on question 5, this is kind of what you were aiming for. And again, you wouldn't get a calculator on our quiz or test for this, but it should point out some stuff pretty quickly to you. Like, I see 2 vertical asymptotes, 2 spikes in the graph. So if you don't have 2 vertical asymptotes for question 5, then that gives you a hint about what you may have done incorrectly. It looks like there's probably a horizontal asymptote around y equals 0 or something close to it. So if you didn't get something similar, then that would be a red flag as well. Because of where this asymptote is, it looks like it doesn't cross the y-axis, so I'm gonna guess that we're gonna not get a y-intercept. And how it looks like it just approaches the x-axis here and approaches the x-axis here, doesn't look like it ever crosses the x-axis. I want to say that we should get no x-intercepts either. So let's work through the algebra to see why all of that worked out the way it worked out. Okay, and I'm going to just do this part first, and then I'll put it on the graph at the end, so I'm not flipping back and forth as much. But y-intercepts are when x is 0, so plug in 0 for x and solve for y. -4 divided by 0 doesn't make sense, so you can't do it, which means this should not have one. What I suspected from the graph. X-intercepts, vertical asymptotes, and holes depend on what numbers make the numerator 0 and denominator 0. Nothing makes the numerator equal to 0. 0 and -3 make the denominator 0. So if nothing makes the numerator 0, you can't have any x-intercepts. If there's not a number that makes the numerator and denominator 0, then you're not going to have any holes. And any number that makes just the denominator 0 should be vertical asymptotes. Which again, it looked like there was 2 vertical spikes in the graph when I graphed it, so that sounds correct. Okay, slant asymptote is when I have to do the long division stuff, but only if the degree of the numerator is 1 bigger than the degree of the denominator, which is not true here. Horizontal asymptotes, since the degree of the denominator is bigger, should be at y equals 0, which is what it kind of looked like. But it could have also been y equals 1/8 or something. I wouldn't guess that just based on the graph. And if I can answer these question types, then I should have a lot of the graph completed. Unfortunately, in this one we have no points, no x-intercepts, no y-intercepts, no holes, So I think we'd have to find a couple more points to get this graph, but we can go ahead and put the vertical asymptotes in as dashed lines. We can do the horizontal asymptote as a dashed line. And again, you need to have some points here to get started. You got to be able to put your pencil somewhere and start drawing. So if you need some points that you didn't just naturally find in these question types, just go up here and plug in some other stuff. Don't plug in 0. I already did that, it didn't work. But maybe plug in 1. You get -4 over 1 squared minus 3 times 1, or 2. So when x equals 1, y equals 2. Okay, maybe I could try at x equals 2. I don't think that would be too hard to do algebraically. Looks like when x is 2, y is 2 again. And I don't know, maybe I'd like to know something about what's going on over here, so maybe I would try -1. I'm just guessing, I don't know. I'm just trying a few. And that would give us -1. Okay, and now I think I've got plenty. Again, I'm just picking x values that I think I could do without a calculator. There's nothing particularly special about what I've got. But now, zooming in on the graph here, if I know it's got to go through this point up here and that point down here, then for this vertical asymptote, he must be going up on the right side and down on the left side. And I can see that he must kind of turn around here, because if this is going down, he's still going down, but he must be turning around to get to this point. And so it looks like he's going up on this side, which means he's going down on this side. And for horizontal asymptotes and slant asymptotes, it tells you what your graph approaches on the far left and the far right. And of course, if you needed more confidence on those, you could make yourself plug in more x values to check. But if I compare that graph to this graph, they look good to me. They look like they're the same. In fact, if you really wanted to look similar, you might change your window settings to be -5 to 5, -5 to 5, just like our graph. And then it should be looking close to identical. So that compared to that, pretty accurate considering how much time we spent on it. So
How do you know if like the one in the middle like doesn't go all the way down to the horizontal asymptote for when you're drawing it?
like right here.
Yeah.
Yeah, and that is a misconception. A lot of times with slant asymptotes and horizontal asymptotes, you guys think that it can't cross those, and it actually can. So there is a chance that this graph did like kind of like snaked through here instead of doing this, and you really don't know until you find an extra point. So just the fact that these two had the same y value, and I knew this was going down, so I knew it was still going down, but I knew I had to turn around, and so that's how I knew that.
So if it doesn't stop the graph from crossing it, what does it do? What does it mean? The asymptotes.
If it had not turned back around,
Like you said, it could cross an asymptote.
correct.
So then,
So what could have happened on this graph, and again, it'd have to be a different function, but it could have gone something like this, like where it did this and then went down. And again, the only way you would know is by plugging in one of these points. And if it went down on that side, it would be up on this side, and your graph would look like that instead of what's in black. But you can cross horizontal and slant asymptotes in the middle of a function. So if it's got 3 sections, it's possible to cross it in the middle. But if you're unsure, you need to plug in more x values. If you're not sure if it goes this way or this way, make yourself try to plug in x equals 4. See that the y value is way down here somewhere and not up here somewhere. The more values, the more points you find, manually, the more accurate your graph will be and the more reliable it will be. Okay, and then for the last part, domain, it hits all of these x values from negative infinity to 0. Then it hits from 0 to 3. And then it hits from 3 forever to the right. Again, domain's a lot easier if you have the graph done. That, and this. Okay, y'all still have about 8 minutes here, so I would like you to do just one more for me, please. If you would try question 6 and do question 6, and while all this stuff is fresh in your head, and before you pack it up for today, read through these definitions that we put in this top chart, and if any of that will be easier for you to work with next week by you renaming it or adding some details or squeezing in a quick example, then please do that. Have about 3 minutes, so try to find a good stopping place here. And again, if you didn't finish at least that one more, then please do that for homework between now and Monday. You do not need to do more than that, though. I will give you. We're going to work on this same handout more on Monday.